Shear force at any point along the beam in a forces that tends to produce a sliding failure on a material along a plane that is parallel to the direction of the force. Bending moment is the moment induced in a structural element, such as beam, when an external force or moment is applied to the element, causing the element to bend. The objective of this experiment is to determine the shear force and bending moment at their particular section, XX section, and compare with the theoretical calculation. First experiment is shear force at cut section due to variation of load and variation of load position. This is point A, point B, point C, and point D, which is at this point, this section XX. Before we start our experiment, we need to make sure that digital force display is 0. First, we place our first load, which is 100, between A and B. The shear force at section XX was measured. Repeat the step by using second and third load, which is 200 gram and 300 gram. Repeat all the steps by placing the load at between B and D and D and C. After all the data was recorded, we plot two graphs. First graph is graph of shear force versus location of applied load from point A, and second graph is graph of shear force at section XX versus value of applied load.
Now, in this test, we have three cases, which is the first case is where the point load is between point A and point B. That indicates positive shear force value. That same goes to the second case, which is the point load is between point D and point C, will also give us positive shear force value. And the last case is where the point load is between point B and point D. That shows us negative value of shear force here. Next, for UDL, 3 or more point loads are being used to measure the shear force at D. The point load must be next to each other with constant distance between the point loads. Then, we calculate the UDL value and continue to calculate the shear force at D. Lastly, we compare the measured value of shear force with theoretical value of shear force at point D.
To prove the superposition of shear force, first we need to obtain the measured and calculated shear force at section XX when the load is at point 1, point 2, and point 3. Then we need to obtain the shear force at section XX when the load is at point 1, point 2, and point 3 at the same time. So according to superposition principle, the total shear force at section XX is equal to the summation of shear force at point 1, point 2, and point 3. Therefore, we can compare the result to determine whether the shear force at section XX obeyed the superposition principle.
First, we need to make sure that the digital force display meter is set to 0 before any load is applied on the beam. 100 gram of load is placed between point A and point B. The value of bending moment at section XX is measured and recorded. Repeating the step by using 200 gram of load and 300 gram of load. The experiment is repeated by moving the load to point B and point D, and also point D and point C. Next, we need to plot a graph which is relationship between bending moment at XX and position of the loads for all three cases. Graph of bending moment versus magnitude of the load P for all the cases is plotted. When the point load is applied between A and B, the bending moment shall always be negative, which we call hogging moment. Whereas when the load was applied between B and C, or point D and point C, the bending moment will always be positive, which we call as sagging moment. Lastly, compare theoretical value and experimental value.
For case 1, the load of 200 grams, the value was placed at point A. Then the load of 170 grams B is placed at 80 mm from point B. Repeat step 1 and 2 by replacing W to 300 grams and B is 250 grams with the same D for case 2. In case 3, the load of 300 grams is placed at point A as W, and the load of 490 grams is placed at 40 mm from point B. Firstly, we applied many point loads where each of the point loads has the same magnitude and the load must apply next to another.
Then we calculate the uniform load by using this equation. And next, we calculate the bending moment at section XX. But firstly, we obtain the RB using this equation. And lastly, we calculate the bending moment at section XX by using this equation. And same for the 3 cases.
So for the superposition of bending moment, first we need to obtain the measured and calculated bending moment at section XX when the load is at point 1, point 2 and point 3. Then we need to obtain the bending moment at section XX when the load is at point 1, point 2 and point 3 at the same time. So according to superposition, the total bending moment at section XX is equal to the summation of bending moment at point 1, point 2 and point 3. Therefore, we can compare the result to determine whether the bending moment at section XX obey the superposition principle.